Okay, so guys, now in this video we have to find the derivative of y is equal to Euler negative 2x and sine 2x. All of the formulas which we need to solve this question are written over here. Let me just go through these formulas first of all. So if you have Euler and you have a function in the exponent, so you can find the derivative of Euler in this case as Euler fx, and then you have to take the derivative of the function. Then the derivative of sin x is actually cos x, and then if it is the product theorem that when two functions are being multiplied, because over here we have first function which is Euler, and then we have the second function which is sine, actually a trigonometric function. So when two functions are being multiplied, you can use the product theorem. What is the product theorem? The second function as it is derivative of the first function plus the first function as it is derivative of the second function. Okay, so yeah, that's pretty much it, and let's begin solving this question. So first of all, let me just rewrite it. Y is equal to negative 2x sine 2x, and after that we will apply the differentials on both sides of this equation. So d by dx, you will learn negative 2x multiplied by sine 2x. So this thing right over here is my f of x, and this thing over here is my g of x. So let's begin. Second function as it is sine 2x, derivative of the first function e negative 2x plus the first function as it is e negative 2x, derivative of the second function. So let's begin. Sine 2x. So the derivative of Euler negative 2x would be, first of all we will write Euler negative 2x as it is, Euler negative 2x, and then the derivative of the function. What is the function over here? It is negative 2x. So multiplied by d by dx, negative 2x. Okay, Euler negative 2x. Derivative of sine 2x is actually cos 2x, of course. The derivative of x, so over here x is 2x, so we have d by dx 2x. Okay, so let's continue. Sine 2x, you learn negative 2x. Okay, so negative 2 is a constant, so let me just separate it, and then d by dx x plus you learn negative 2x. Over here we have cos 2x, and the 2 will be separated and dx will be cancelled by the x right over here, so we are left with the 1. Okay, then sine 2x, you learn negative 2x, negative 2, this will be cancelled and we are left with 1 plus you learn negative 2x cos 2x along with the 2. Okay, so we can see that the negative 2 over here can be written separately, so we can write negative 2 sine 2x, you learn negative 2x, because all of these terms are actually being multiplied, plus over here 2, we have 2 over here, so we can separate it, so we can write 2 you learn negative 2x cos 2x. Now if you see, we have Euler negative 2x over here, and also over here in this term we have Euler negative 2x. Over here we have 2, and over here we have 2. So we can just take out these terms common. So 2 Euler negative 2x. So we are left with negative 1. Of course 2 will be divided by the 2, so we are left with a negative 1, because we do not have the negative sign in the second term, so we cannot take it as a common. So the negative sign will come as it is, and we are left with a negative 1. Then we have sine 2x. Obviously Euler negative 2x will be divided by the Euler negative 2x which we have just taken out common. Over here 2 Euler negative 2x will be divided as a whole, and we will be left with cos 2x. So we are left with 2 Euler negative 2x. We can rewrite this term as cos 2x minus sine 2x. Okay, so I hope you get the point.